So we start our sections, okay? We need to learn, so we'll go through before we can become a good statistician, okay? So let's look at the intro. So this note is obtained from some people did it, David M. Lane. Okay, there are many, so we use it or whatever. Some people mention it, but it's you write it when you there are a lot of authors and you don't want to mention all of their names, so you write one of them and then you bring that. So introduction to statistics page, copied from page something. So this is a very good idea when you are trying to lift somebody's work or pick an idea from somebody's work and then bring it into yours. At least it's better you recognize the person by citing the person. So that's exactly what they've done. So we'll look at the things, but before we would go through about two of them, and then the rest will be scheduled for the next lecture. Okay, so we'll look at descriptive and inferential statistics. But before that, let's look at the prerequisite. What is statistics? Okay, so statistics, for here they're saying statistics is the course you are studying right now. It means some of you are studying statistics, others too had interest in that, probably couldn't offer, others too just have interest, even though they are in a different field, they want to have a field of statistics. That's why they are here. Okay, so also known as statistical analysis or statistical inference. It is a field. What is it? It is a field of study concerned with summarizing data, interpreting data, and making decisions based on data. So the whole idea is data. Okay, so let me give a typical scenario. You go into a community, you want to set up a business. Okay, you just go there and do the business. No, you look at a community, seems like a poor community, a rich community, you are not very certain, so you would want to do a survey as a start man before you set up the business. Okay, so you would get a data, summarize the data, then you interpret the data. Per the interpretation, you can make decisions. Is that to go ahead and do business, and what kind of business are you supposed to even do? Should it be something that would be very expensive for the people living in a community? Okay, you look at all those stuff. So let's look at this. A quantity calculated in a sample to estimate a value in a population is called a statistic. So what this one means is that if there's a quantity and then you calculate that from a sample. Now what's a sample? Now if the community, you came into this community and then it's a new community to you, right? There are a lot of people living in it. You want to do your survey before you set up your business. You won't be able to capture everybody. Even your resources might not be enough to look at everyone living in this community. So you will take a portion. So if there are 5,000 people living in the community, you decide to take 100 of them. That's a sample. It's a portion of the population. You pick them up, okay? And then you go there. So you are looking at the average salaries. You want to know the average salary, okay? So you go there. Mom, what's your average salary? What's your salary per month? Oh, this person, what's your salary per month? Yeah, you collect the data. After you've collected data, as a stats man, you sit down, use your softwares, and then calculate the descriptive statistics. Okay, that will be the mean, standard deviation, percentiles, interquartile range, and stuff. Then you calculate them. Okay, so those things I'm mentioning, you calculate the mean. You use a sample and then you calculate the mean, and they are saying that the mean salary of this community is 10,000 Ghana cedis, or 5,000 Ghana cedis, or 100 Ghana cedis. That value, you didn't use the whole population, okay, but you have used a sample, calculated the mean from the sample to estimate the population parameter. We say that is what a statistic. But if you should use the whole population to find the mean, that value is called a parameter. But if you use a sample to find a mean, that value is called a statistic. Okay, so take note of that. Take note of that. Take note of that. So there are some related terms. Data science, data analysis stands for a study of processes and system that extracts knowledge, insights from data in various forms. So it's an advanced version of statistics. When you do statistics, you can go ahead and do data science, and that's interesting because you would have to pick knowledge, insight from data. So you see something that is raw, you go and pick 2, 3, 4, 5 male, females. That you pick them, and then they are just raw fact. But a data scientist will look at it and pick knowledge and insight from that. Okay, right. So look at the structure of statistics. So this is a typical structure of statistics. We have a descriptive statistics and inferential statistics. So what I talked about earlier about the community, you calculate mean, standard deviation, all those things are what we call descriptive statistics. They don't just end there. Okay, so in summarizing data with a descriptive statistics approach, okay, or presenting your results and stuff, you would have to use numbers and visualizations, or something that to graphs. So let me say graphs. Okay, so use numbers and graphs, okay, to show your the process data. So you pick a raw fact like the community, you pick their salaries, okay, all right. Then you would want to see that their salaries, okay. You can probably categorize them, group them into category. Those who take salary from a certain number to a certain number, from that or that, then try to plot and see. Maybe you can use a histogram, okay. You can do a bar chart. You can do a lot of stuff to see what is happening. You can calculate mean, variance. That is descriptive statistics. Okay. So for inferential statistics, it's a very nice aspect of statistics. For that, we draw conclusions about a population based on the data observed in the sample. So now you calculate the mean. Alright, is that mean actually what you will get if you should use the population? That question can only be answered with an inferential statistics. Okay, alright. So this is a data science process. It just works like anything else. You get your raw data, you process the data. Sometimes when in higher data scientists, you have to clean up the data. Even if in lower one and you get a certain data, you have to clean up the data set, right? You use computer, so you get the model, algorithms and stuff. You communicate, you see, you put in the reports, and then you make decisions. That's basically what you do. Then you can have data analysis processes. Okay, so descriptive, you can use graphs. Okay, analysis. This analysis explore relationship between variables. This is pure inferential statistics. Compare groups, inferential statistics. Okay, so this is what has been done. You use graphs and stuff to show something. That's descriptive statistics. If you should use compare groups, you want to understand why this is that. Okay, you want to find out whether what you've got for the sample will be the same for the population, or if there is a relationship between something. You wouldn't have to use inferential statistics. Okay, so we are going, that was just an explanation, so let's delve into it. So this is descriptive statistics. So descriptive statistics are numbers that are used to summarize and describe data. Descriptive statistics are just descriptive. They do not involve generalizing beyond the data at hand. So what you have at hand, you went and then you took sample. So 5,000 people are living in the community. You took a sample of 100. These 100 people you took, you calculated the mean salary. That is all what you have. You can't infer, you can't say that, yeah, because I have 100, it means indeed it's true that my population salary is that. Okay, that's a question, or that thing descriptive statistics cannot do. All right, you can actually prove it. So the data you have at hand, you can probably make conclusions on the data you have at hand. Okay, so descriptive statistics is a collection of methods of summarizing data. So you can use mean, median, mode, range, variance, percentile, interquartile range. All right, all of these can be done. Okay. Some people go ahead and use ketosis, keenness, and stuff.